Everyone, so in this video, I'm going to talk about a like a new shorting algorithm, which is basically quick short. It is also different from like the other previous shorting algorithms what we have done till now, which are basically bubble short, selection short, insertion short, and counting short. And its time complexity is pretty good. Like it is good actually. It is better than any other time complexities of like algorithms of shorting algorithms, basically nlogn. So it is very efficient algorithm, and its logic is also very simple, not very complex also. Okay, so we have to like the previous videos, we will first of all see what is the explanation of the quick shot, that means how it works, and then we'll deep dive into the code of the algorithm, and then also we'll discuss the time complexity, the space complexity of the algorithm. Okay, and in the upcoming videos we'll like shorting algorithms like merge short, cyclic short, and another thing, in this quick short, we generally need the concept of the recursion. So if you don't know what is recursion is, maybe if you are seeing this video maybe a couple of months later, then the recursion video will be there in the Java course. But in this for till now, we don't have basically maybe you don't have a knowledge of the recursion, right? So I'll be giving some basic like knowledge of the recursion, just basic. But in the upcoming video, I'll be explaining that the recursion in a, like in depth, okay, with the codes and examples, etc. The questions also. So so let's get started with the quick shot, right? Okay. So quick shot, quick shot. So what happens in the quick shot? Of course, there is shorting algorithm. So that means it will arrange the list of elements in ascending or descending order. So suppose you have a list. Suppose we have a list of elements, which is basically uh, like let's give an example 35124. So I took this example, like it's not a random. I guess like the values are random, but this example is unique because it will explain the quick shot to you in a very good manner. All right, because it will generally go like what is the basic concept of quick shot. It will really go beyond that. So how it will do like first discuss about the basic concept of quick shot. What happens in the quick shot? We take a pivot element in a quick shot. Pivot element means in a random element. Okay, in a random element in the quick shot. It can be the middle element, it can be the last element, or it can be the any element. But by convention, people may take the last element, and it is good to take the middle element as the pivot. Okay, middle element as the pivot. It is the pivot element. It is the pivot element. Pivot element. Okay, this one or this one is the pivot. Let's for this tutorial, we will be taking the middle element as the pivot element. Okay, take middle element as the pivot element. Don't like the implementation will change depending upon the what pivot element will take, and it is easy. It's not that tough. Just you have to take the change the pivot element. Like we're taking here the middle element, you can take the last element also. The implementation doesn't change that much. Okay, so yeah, so we'll take the middle element as the pivot element. So what happens? We are what we're doing actually. Let's take another example. Could I already said this is a different example, really an interesting example, but let's take a different example to like two 4 uh 3 1 and 3 1 and 5, suppose. So 3 is the pivot, right now, right? 3 is the pivot. So what are you doing in quick short? We what we select as a pivot element, we place it in the correct position by swapping, basically by swapping its left hand side and right hand side elements. That means whatever the less value, uh, the less value than the pivot is on the right hand side, will be on the left hand side, and whatever the greater than value, like the 4, is on the left hand side, will be go on the right hand side. That means suppose like 1 is less than 3, right? It should be here, so it will be go here, what actually happens, it is I equal to 0, it is j equal to 0. Sorry, j equal to, here it is j equal to 4, right? J equal to 4. So it will check if 5 is greater than like 3. So okay, it is greater. That means it is the correct position for it. It is the correct side for it. Okay, so it will stay as it is. So j will be decremented. Now j equal to 3. Now j equal to 3. And it'll say, is it okay? It is okay. So now it will be swapped. And then I mean I'll be incrementing. Like 2 is less than 3. 2 is less than 3, and that means it is in the correct side. It will on the left hand side of the 3. So it is in the correct position. But so I'll be incremented to I equal to 1. I will say if if 4 is less than 3, it is not 4 is greater than 3, right? So now it stop, and if if 1 is greater than 3, it's not. So 3 is also stopped. Now it will swap. Now it will swap with each other. Okay. So now what will it became? It became 2, 1, 3, 4, and 5. Now 3 is in the correct position. 3 is in the correct position. Here it is in a not correct position. Not in the correct position. And here it is in the correct position. Right? 3 is in the correct position. So now the same thing we have to do here, and the same logic we have to apply here by taking a pivot element here. A pivot element can be this, pivot element here can be this. Okay, that means again we have to do it again when we are like doing here. So again we have to after the pivot element get placed, again we have to uh, mm, uh, apply the quick shot in its sub list. So this is basically a recursive solution. Okay, this is a recursive solution. It can be done using recursion. So let's first talk about the recursion. Like, right, if you don't know about recursion, let's talk about recursion, because otherwise you will don't get it. What recursion is? Recursion, and then I'll explain in detail, like in step-by-step manner, how this list, I said this list is something different, so how this list will be get sorted, right? Okay, so let's get started. So recursion. So what is recursion? Recursion is calling a function by itself. It's like calling a function by itself, by itself. So if you don't know about functions or anything, maybe if you come back in a couple of months later, right? So those concepts are already covered in the Java course, but for now, you just like assume that the function is a block of codes, okay, that it can call whenever you need. It is like a reusable code, which you can use in any part of the program, any number of times whenever you want, right? So it's calling a function by itself, and recursion is calling a function by itself. That means suppose you want that you want that 4, like you want that 4, uh, someone want to be 4 dependent. This is a function. Suppose this is a function to print a number. Print a number, right? So we are passing 4 to it. We're passing 4 to it. So it will print 4. It will print 4 output. right? It will print 4. Now, if someone want to print 3 on it, so what will do? We'll pass 3. But what you have to do, step by step manner, you have to again uh, like call print like this. 3 print 2 head and so on. So thus it will print 4 3 2 and dot 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 other things. Okay. But what happens in recursion? If you made a function and want and there is a thing you can pass it some value, and in each pass it will give you a different result. Okay. Uh, in that case, so if you have a recursion condition, if you have a recursion condition, so or a recurrence relation, I will get to it like later. What is the recurrence relation is? We'll do the time complexity chapter, time complexity video. So for now, you just understand what happens. We are passing here 4, right? We're passing here 4. But what happens if you pass here 3? So it will also print 3. But pass here 2, you also print 2. So there is no need to write this statements, right? No need to write these statements. Because why would write the multiple statements? Where there is this one function, and we can put like call the function multiple times. So that thing is called recursion. That means now if we call now here in this case, like in this case, let's first erase it. Okay. Okay. So in this case, if you write this function like this, some modify this function like print, and there's a function like little bit bigger, and we'll print 4, and we'll call this function again, and we'll call it like this, like 4 minus 1. Okay. So whatever we are putting it here, like we are putting first of all 4, so it'll come here and it will do 4 minus 1 and will print it. That means this will 4, that will 3 3, then 3 will be printed, and again 3 will be called. 3 will be called, so it will now be go, and it will be 3, and here would be 3 minus 1, and so it will be 3 also, and 2 also. So that's how it works actually. Okay, that's how it works. So it is like calling a function by itself, like within itself. So that's recursion. So we'll like get to it in more depth, like by like the concept of stacks and stuff like that, in a specific video of recursion, which we'll be doing in the Java course. But for now, just understand it is calling a function by itself. Okay, that's all. Now let's do the step-by-step explanation of the quick shot, that example, that like special example you can say. So like list, we have, what do we have? 3 5 1 2 4, right? 3 5 1 2, yeah. Yes, so 3 5 1 2 and 4. So what will take, we'll take the middle element as the pivot. We will like uh, step 1, 3 5 1 2 4. We'll take middle element as the pivot. Take middle element as the pivot. Okay, so here's the pivot. Here's the pivot element. So the pivot is, uh, just erase it. And pivot is middle element 1. Then I is now 0. J is the length of the list minus 1. That means it is length of the list 1 2 3 4 5, minus 1 is 4. Why is minus 1? Because array starts with from 0. So if it is 0 1 2 3 4, it would cover the 5 elements. Okay, you don't need the fifth index, which is not here only. So if we do it, so I equal to 0 here, I equal to 0, and j equal to 4, right? So this is the thing. So now it will check what check it will do? It will check, first of all, it will find uh, find an element which is a find element in the left hand side of the pivot, which is basically greater than 1, really greater than 1, and then it will stop. So if we do I equal to 0, so what will happen? It will say, okay, in case of the first step, in the first step, it will say, okay, 3 is greater than 1. So it will stop here only. It will not increment I by 1. It will just stop here. And in case of the right hand side of the pivot, check equal to 4, and it will check if the right hand side of the pivot has some element which is less than less than the pivot. So if it is at some if j is at 4, so this element we don't need it. Like this element is greater than pivot, so we will decrement the j until we find an element which is less than the pivot. So it will decrement. So what will happen now? We'll decrement it. So what will happen? We'll do 3, 5, 1, 2, and 4, and j decremented to j equal to 3 and I equal to 0. Okay, so here we'll see j equal to 3. Yeah, j equal to 3. Okay, so j equal to 3. Now if j equal to 3 is basically less than 1, it is not, right? J equal to 3 is not less than 1, so it will again decrement it. It will again decrement it. So what it will do? What it will do? It will just do 3, 5, 1, 2, and 4. Then it will again decrement it. It will go to j equal to 2, which is basically the position of the pivot. It will do j equal to 2, and it will be j equal to I equal to 0. Okay, so j equal to 2 and I equal to 0. So 3, 5, 1, 2, 4, j equal to I equal to 0. Now check if like 1, uh, if 1 is less than 1, so it's a no. It won't say is equal to, it say less than 1. No, it is not less than 1. It means I is not less than 1. The 1 is not less than 1, right? 1 is not less than 1. It is 1 is less than equal to 1. Less than or equal to 1. Okay, so this is true, but this is not true. But we are checking this condition, so it is not true. It means it's stopped here. J will be stopped here. Okay, so here it is 2 only. Here 2 only, and J will be stopped here. Okay, in the pivot. Now what it will do? It will swap these two elements. If it will swap, if I is less than 2. Okay, yeah, sorry, I is less than j. I is less than j. If this condition I is less than or equal to j, if this condition is satisfied, then it will swap it. And also the loop will continue to execute until, like step 1 will execute until the I is basically I is less than or equal to j. The exit condition is the where the step 1 will be stopped. Condition is where exit condition is where I is less than or equal to j. That is the exit condition. Okay, so that is the case. Now what to do? It will swap it. Now what will happen? It will do 1. It will swap these two elements, and it will do 1, 5. Okay, 1, 5, 3, 2, and 4. Now the pivot is at the correct position. Okay, now the pivot is at the correct position. This pivot is at the correct position. But what will happen? The loop will the algorithm doesn't know that pivot is the correct position. How could it know? Because the condition, this exit condition didn't satisfy till now. It is the I is 0, and less than or equal to 2. So the exit condition isn't satisfied till now. Okay. Since the exit condition is satisfied now, it will continue to ready to work. So it will say here's I equal to 0, here j equal to 2. So it will say if, again it will say if I is equal to 0, basically I equal to 0, uh, I equal to 0 if power is still 1, right? Power is still 1. So if 1 is less than 1, it will say no, 1 is not less than 1, 1 is less than or equal to 1, 1 is not less than 1. So it will stop here, and she will be say if generally 3 less than 1, like 3, or like it is the left hand side. So if there is some element which is greater than 1, if like it is j, so 3 is less than 1. So if what is less than 3, okay, 1 is less than 3, so it will say yes, whatever it has, like where we are is correct, that the j value, like 1 is less than 3. Okay, 1 is less than 3. Now what will do, it will plus it, like it is minus it, right? It will minus it generally. Go ahead as 1. We'll check 1 is greater. We'll check 1 is greater and that is smaller. It will check that, right? 1 is greater, 1 is greater and 3 smaller. Uh, yeah, so 1 is greater, and 3 smaller. That means it will check is some elements which is less than pivot but is greater, right? So it will decrease the value of j. So it will decrease the value of j. So it will decrease the value of j. It will be 1. Now it will become, the list will become 1, 5, 3, 2, and 4, and I equal to 0 and j equal to 1. Okay. So now again say, okay, this is greater than 5 is greater than 5 is greater than 1, but we need less element. So what it will do, it will do decrease the value of j. It will decrease the value of j to 0. Now it will be 0, and here it will become 1, 5, 3, 2, and 4, and I equal to 0. Okay, sorry, uh, I equal to 0 and j equal to 0, right? It will at the same position. So here this exit condition satisfies, and it will get out the loop. It will get close. And after the step 1, we see our pivot element is at the correct position. Our pivot element is at the correct position. Now what I have to do, basically it will like it will swap it until until it's good, like maybe the condition will not be for the equal to, is I is less than j. When this condition then only it exit. That means another loop will continue to happen, and it will swap it. It will just swap it. That means it will cross it, cross it, the 1, 5, 3, 2, and 4, and I'll be go here. I'll be equal to 1, and j is equal to minus 1. Okay. Now from this one, from this side, again we'll take the pivot element, a pivot element, and continue to do the same process. Okay, continue to do the same process. Now, now here, suppose the pivot element is this, pivot element is this. So this is the step 2 now. Actually, step 2. And it will continue to do the same process. That means this is the private element, and for this is the I equal to 0. This is the, here the I equal to 0, here the I equal to suppose whatever the 0, 1, 2, 3 equal to 3. Now it will also do the same process. Actually I equal to 4 only, and it will be I equal to 1 and I equal to 4. Now it will continue the same process, and it will place the pivot element at the correct position. It will place the pivot element at the correct position. uh, so that's the explanation actually. So if you want that, I can like explain the below processes also, the steps also. So in the step 2, what will happen, in the step 2, I have a 1, 5, 3, 2, 4, right? 1, 5, 3 to 4, 3, 2 and 4. Okay, 1, 5, 3, 2 and 4. So this is already shorted, right? This is already shorted. So we need to bother about this particular section. So let's take this the pivot element. So pivot is 3, I equal to 1. So the I equal to 1, and here in this case j equal to 4 only. So j equal to 4. Okay. So j equal to 4. Now this is the pivot element. So we'll check if mm, uh, 5 is greater than the pivot element in the left hand side. Yes, it does. So it will genuinely, what it will do, it will stop here. We found a match, we found a greater element, so it will stop here. And now is the case of j. Now in case of the j, I will check if we found some element which is less than 3. No, 4 is not less than 3, so it will do what will do, it will 1, 5, 3, 2 and 4, and yeah, 3, 2 and 4, and j will be here, j will be decreased. Okay, j will be decreased, j equal to 3, and then the pivot element, and I equal to 1. Okay, so now j equal to 3. Now it will say if 2 is less than 3, we say yes, it does. Now it will stop, like here it will be change, it will be 3. Okay, now here will change, it will swap these two elements, and it will be like 1, 5, it's okay, 1, 2, 1, 2, 3, 5 and 4. Now see, 3 is at the correct position. Now see, 3 is at the correct position. So yeah, 3 is at the correct position. That is great, because 3 will be at the third position, right? They will be correct position, but the rest of the elements, like these elements, are not shorted till now. So j equal to 1, like I equal to 1 and j equal to 3, right? Now it will again say I equal to 1, like I equal to 1 and j equal to 3. Okay, now it will again say if there is some elements, like 1 is an element which is greater than 2, it will say no. So uh, like greater than 3, actually greater than 3, in the left hand side it will say no. So I'll be decremented because it didn't find a match. So I'll be decremented. That means it will become okay, 1, 2, 3, 5 and 4. So it will become equal to 0, and j will also be decremented because there is no small elements like which is less than 3 in the right hand side. Okay, so it will be I equal to 0. mm, so it will be I equal to 0. So yeah, no, I'll be incremented, so I'll be 2 equal to 2, and j will be decremented, so j will be 2. So it will be uh, like 2, 2 and 2. Okay, so now again it will check if 3 is, like 3 is greater than 3 and 3 is less than 3, which both the conditions false. So I'll be incremented, j will be decremented. So what I'll do, so this is the our case, and we'll do 1, 2, 3, 5 and 4, and I'll be incremented. I'll be 3, I'll be 3, and j will be 2. So now like j will be 1, j will be 1. So here in this case j will be 1. In this case it will be 3, right? I'll be 3, j will be 1. So these conditions means I should be less than j. This can get false. That means this step 2 will uh, be terminated. Now this pivot is at the correct position. Now what we'll do, we'll take this one, because this is something, this is already in the correct position, but we'll take this one, and this one. So in the step 3 we'll have two lists. We'll have, okay, in the step 3, okay, sorry, really in the step 3 we have a two list, which is basically one is only two, one is only two, and we'll say here I equal to 0, and sorry, I equal to, not like this, let's say we have 1 2 3 5 4, right? We have 1 2 3 5 and 4. So in the first case, we in this case, in the first list, we have I equal to 1 and j will be also equal to 1, because this is the only list, right? So now in this case, because both are like equal, so it will get terminated, and it will get terminated, of course, in the first case only, in the first check only, and it will be because in the correct position, right? So 1 2 3 5 and 4. Now we'll have this list, because in the previous case we have separated out into two lists, because it is the recursive solution. So we separated into two lists. We'll see how it recursive solution works in the analysis of this time and space complexity. But here it will be, we have 5 and 4, right? So 1 2 3 5 and 4. So in the 5 and 4, we have here we have I equal to, like 0 1 2 3, I equal to 3, and I here I equal to 4. So in this case, the pivot element, suppose pivot element is this, the pivot element. So here the pivot element is 5, I equal to 3, and j equal to 4. Okay, so now it will check if, like, if 5 is like if 5 is less than 5 in the right side, so 5 is not less than 5, so I'll be there only. Now 4, in the fourth case, if it will say if pivot element is in the right hand side, if I remember there is some element which is less than the pivot element, that is less than 5. Yes, 5, like 4 is less than 5, so j will be decremented. No, oh, sorry, not j will be decremented. There is a, we get something which is really less than 5. That means it is the case. It is the case. So get the case j equal to 4. Now it will swipe. It will swipe. If it didn't get less than 5, so it will search for it and will j will be decremented. But in this case, we get it in the at the first place. So the j didn't decrement it. It will swipe this one. Like 5 and 4 will be swapped. So that means it is 1 2 3 4 and 5. Now see, the whole thing is shorted. Now it will be I equal to 3, right? Here it will be I equal to 3 and j equal to 4, and the termination condition, here it is. So it will say if I has some value, if I has some value which is less than the pivot, but basically greater than the pivot, so it doesn't. 4 is basically less than pivot, so it will stay here. And in the j, we'll say if pivot is basically has some lesser value on the right hand side, so 5 is not less than 5, so it will generally decrement it. It will decrement it. Basically it found a check, that's why it is stopped here, and it didn't found a check, that's why it is decremented. That means what will became 1 2 3 uh, 4 and 5, and I equal to 3 and j equal to 3. So I equal to 3 and j equal to 3. Okay, so now again, like the condition, the condition will be checked, and I'll be incremented, j will be decremented. I'll be incremented 1 2 3 4 and 5. I'll be incremented like I equal to, 4, and j will be decremented, j equal to 2, right? J will be decremented, I'll be incremented. So that means j equal to 2, j equal to 2, and I equal to 4. Okay, so now we have to check the termination condition is I is less than j, that means 4 is less than 2, its condition, this condition is false, right? So step 3 will be terminated. So now you can see this list is shorted. This list is shorted generally. Okay, this list is shorted, and we've done it in a very clear step. It's looking like it is 3 pages, but for the explanation it's needed 3 pages, but it's really a simple explanation, I would say. Okay, so let's get started with the time complexity in the space complexity algorithm. So the time complexity, time complexity of the algorithm. Okay, so its time complexity is very efficient. This is nlogn. How it will become nlogn, we'll see here. So let's see. So we suppose we have elements. Suppose we have a elements like here. In this case, it is like what to take as an example is 3, 5, 1, 2, 4, right? In this case, this is the pivot. We will place it at the correct place, and this two will be go uh, not this two actually, but assume that this two go at some place, and this two will go in some recursive call. That means it is separate route. Assume that assume that this is at the correct place, although it is not. Assume that this would be go at the some position, and this would be go at some position. Okay, uh, so it will be 3 and 5. Now 3 there will be 3 uh, and there will be 5. See, here's a 3 5. Okay, here's a 3 5. Now 3 5 will go in two steps, basically 3 and 5. Suppose I'm not talking about anything else, I'm saying suppose, because actually in the quick shot it generally happens something different, right? So we cannot say it like that. This so what happens? Suppose here we have a 5 steps, right? Here we have a 5 steps, right? So here we have a 5 steps, but here we have 5 steps, and in this case, like here is one step, like here is a one like total array, one total array, one total array, and here we have a total array, and we have a four total array. So what happens here? Here is one, it is 2, and it is 2 to the power square. That means for n elements, like here's a 4 element. Okay, here is a 4 element. We have a 4 elements. So for n elements, what will happen? For suppose it will go till 2 to the power k. It will go till 2 to the power k, right? So for n elements, n for n elements, 2 equal to n equal to 2 power k. Okay, n equal to 2 power k. That means if you say log on both sides, log n equal to k log of 2. Okay, that means k equal to log of n. That means k equal to log of n, right? So yeah, that's it. It is log of n, but that means it is not log of n actually. In each cases, in each when you're selecting the each case, but here we have two checks like I j, two checks. Here we have one check. Here we have like what are the checks? Like 5 checks actually. 5 checks, 2 checks, one check. Like what is the length of the limits? If you have n elements, so it will be n check. If here with 2 check, one check. For each element we have n checks. For each cases we have n checks. So for each cases we have n checks. That means if we plus all these checks, there's one check, two check, three check, up to n check. We plus these checks. So if we plus these checks, uh, plusing the checks, plusing the checks. So it will be one check plus two check plus three check up to four check. Sorry, up to n check, up to n check. So it will become 1 plus n divided by 2. Okay, so 1 plus n, 1 plus n divided by 2. And in the previous cases, the number of you can say uh, elements, like the number of steps. There's a number of steps, like one step, two steps, three steps, up to k steps. So number of steps is basically log of n. It will take log of n steps. That means time complexity. That means time complexity basically 1 plus n divided by 2 into log of n. That means log of n divided by 2 plus n log of n divided by 2. So this is a less dominating term, so it will remove it, and this is the constant, will remove it, so that will our time complexity will become, so our time complexity will become, so like time complexity is nlogn in case of quick shot. And if you look at the space complexity, and now if you talk about the space complexity, it is big of 1. Why big of 1? Because we didn't use any extra auxiliary space for the shorting of this algorithm. So it is basically big of 1. It's constant time complexity, like the other shorting algorithms, like previous shorting algorithms, like bubble short, section short, insertion short, is also same. Uh, so that's the whole time complexity. It is very efficient time complexity. It is n log n. It's very good time complexity compared to the other sorting algorithms. Okay, so space complexity is of 1 and time complexity is this one. And this is the explanation. So now let's jump into the code. You will get more like the more a little bit more of it, like the quick shot, more of it if you get the code. So let's get the code and the applet. Let's go. Here's a applet, and here we have a CodaGo folder. We'll go to that, and in there is shorting subfolder. Here we get the previous codes of shorting algorithms like counting shots and short, section short, bubble short, and we'll get a REPL here, which is basically on the Java, mm, on the Java, and here we'll do quick shot. We'll do quick shot, create a REPL, and I'm creating a REPL here on quick shot. So you will get this code in the description of this video. So let's do it. So quick shot. So what happens in the quick shot? So let's make it another function of it. Let's take an array. So array, and we'll take the same array for now. So what's the array? Literally 3, 5, 1, 2, and 4, right? And okay, for now let's create another function because we are using recursion, so we need a function because recursion means calling a function by itself. So we need a function actually. So let's make a function static. We'll see why I'm using static, what is the return type, why are we using those kind of things. We'll see everything in the Java course, but for now let's make a function. Everything we do be doing in the Java course for now. Let's don't get into that part. Static void, like static, and will be integer, turning in integer array actually, array, and we'll do quick short, and we're taking the integer array, and we're taking a start, and an end, like, or you can say the low, which is defining the lowest index, low and high, high. Okay, low and high. So first of all, what we'll check is low and high, like we'll check if low is less than or equal to high. Basically low should be less than or equal to high, right? So if low is less than or equal to high, so basically if low gets greater than equal to high, not less than equal to is okay. If greater than equal to high, then this is not good, right? Low cannot be greater than equal to high. That means in that case we'll return it. Return the array. Okay, we don't have to do anything. We return the array. In the other cases, what we do, we'll check while low is less than high. Until low is less than high, this loop will be continued. And another thing we'll do, not low actually, so we'll do integer, like integer. Suppose we're doing it start, you are taking a start. Okay, let's start as equal to low, and end, we'll taking as high, and we'll take the pivot element, and pivot element is equal to so the middle element, pivot element is equal to actually, we'll say like middle element, like, so you can say s plus e divided by 2, like, right? Pivot element is arr of we will taking s divided by s plus e, divided by 2. That is the pivot element, right? So we'll doing again, we'll do while while pivot is while pivot is, while basically the left hand side, like ARR of S, left hand side is, if it found a less element, here is less, and pivot is greater, so that is true, like in the left hand side is okay, so we don't do anything. Okay, in that case we have to increment it to find a greater element than pivot, so we have to increment the S. And in the other case we will have E to ARR of E if ARR of E is greater than the pivot, so we will decrement E by 1. So decrement E by 1. Okay. Okay, so and now we'll give a swapping condition. If S is less than or equal to E, in that case we'll swap. We'll do the swapping is same as before. Error of S and error of S is equal to error of E, and error of E is equal to 10. That will be the same as before. Now it is done. Now what we'll do, we will like call the pivot, but here in this case actually it is returning something, right? Returning ARR, return from the element. Basically I should use void, I guess, here, because we're not returning anything. Actually we're not returning anything, we're just making the quick shot and we're not returning anything. Is we returning anything? No, we're not returning anything. So I think void would be great, and here we just return, and here we're doing quick shot, like the recursive call, doing the recursive call, right? We're doing the recursive call like quick shot, and here passing the array, and from where we're starting, like from E, like the uh, next condition will be start from here. What will stay? See, like here will be j equal to -1 and I equal to 1. So I from I equal to 1. That means from S to the end. From S to the end, what is this one? And from low, like uh, from low to the J, actually we have to go. Like if it gets here, basically from low to the J, low to the end, and from S to the like S to the high. From so first of all from low to the end, and quick short here are of like from the start, like whatever the start to the high. Okay, that's the thing. I think it will work. See, quick short, let's call the function quick short this low. Okay, low in this case we are taking as 0, and high is the length, the array -1, length -1. Okay, and here printing the array, printing the array. So for print I 0 is less than dot length plus plus. Okay, so system dot print length, so we'll take error of I. So just run this code now. It will work, I guess. Let's see, is there any error? Okay, it is taking a little bit of time. Okay, it's taking time. I don't know why it's taking time. Maybe because the CPU is at its peak, like it is using all the resources. Maybe because of that, but it should happen. Should work. Let's run it again. Okay. Maybe this can't handle that kind of cursor calls. So maybe we could go to the another editor. We can go to SolidLearn for now. If you don't know what is SolidLearn, this is basically a very good uh, learning platform. Uh, Not for the advanced level, but for the beginners, it's very good. You will get quizzes, you will get like the code bits, you get playground, everything you need. You will get here. And after completing the challenges, you will get like badges, lots of badges, and there are also levels. I'm at a level 15. I'm not using Solidon for a long time, but recently I opened it. It's a good one. It's not bad, but it's not good when you are taking inputs, because it will take the input at a like all the inputs will take at one time. So that thing is not good. Uh, let's go and copy this code. Let's stop it. Let's copy this code to here, to here actually. Let's place it here. Let's copy this code here. Okay. Let's run it now. Okay, maybe here is some issue. I think there is some issue. Plus E divided by 2 the error pivot whose low is less than high, or low is less than high. That will work. Okay, okay, what to do? So we have to decrease here also. To decrease here. You have to decrease, like increase as here, and also decrease here. We swap, right? So now we don't have to check that particular thing. So we can generally do like plus plus and minus minus here. Maybe now it should work. No, not working. There is some tedious one. We're taking low and high. Uh, E, low and E we're taking. I'm taking if low is greater than or equal to high, so we'll return it. And here are of S and high. We have S and we have a high. Uh, from S to high we'll going, and yeah, I think it should work. Hmm. Why it's not working? I didn't get it. But it should work. Here of S should be, if it's less than that, so it'll okay, so we'll plus it. If it's great, that part is greater than, so we'll need a small element. Okay, so for that stopped, and maybe S is less than of E. I think it should have a if condition. Okay, so it'll go and like in check, right? So there is a while Flip there. So it should work. I don't know why it's not working. Let's go to applet to s plus plus e minus minus. Okay, let's run it now. No, it's taking lots of CPUs. It should be okay. 0 to era dot length minus 1. That is the start and that's the end. Length equal to high. Average error of s plus e divided by 2. Okay, not s plus, yeah, it is s plus e because low and high is equal to s and e. Um, low is greater than equal to high, then it will return. Otherwise, it will continue. Okay, okay, it is low. It is not low. Yeah, that's the condition. I have did wrong here. My mistake. That I have did wrong here. Silly mistakes. Yeah, now it's sorted. Now it's sorted. So that is a silly mistake. Now it's sorted. So that's the whole video of the thick short algorithm. Hope you like it. And people do silly mistakes, you know. The code is always silly mistakes. I gave them low and high here, but it should be S and E, like start and end. So that's the code. You will get this code in the like the description below. You know, in my replit account. If you want to like practice it, you can do it. If you want to like you can understand, you can go to the previous timestamp and replay it. Okay, that's the whole video. So hope you like the video. If you like the video, you can share it on social like the Twitter and the LinkedIn. Like if you're learning in public, then take a screenshot and share it in social media, and that would be great. Okay, so see you in the next video. Bye bye.